Bismillahirrahmanirrahim. Hi everyone. I hope you are all doing well. I welcome you all in class of real analysis by Robert G. Bartle. Here I am using the latest edition, that is the fourth edition of this book. In today's lecture, we will discuss three questions, question number 12, 13, 14 from exercise 1.1. So let us start from question number 12. These questions are actually related to the direct images of a set under some mapping f. So question number 12 is, we have a given function f of x is equal to x square, and there are the two sets E and F. Set E is a set of all real numbers that lies between -1 and 0. Both are included. That is, set E is a closed interval from -1 to 0. Similarly, the set F is, this is the closed interval from 0 to 1. The first question is, show that the intersection of E and F is a singleton set that just contains 0, and the f of E intersection F, that is the direct image of their intersection under mapping F, is 0 set, while f of E is equal to f of F, and this is equal to the closed interval 0 to 1. And hence show that this set f of E intersection F, this is the proper subset of f of E intersection f of F. And the last, he says, what happens if 0 is deleted from the set E and F. So let us discuss each part one by one. It is clear that our set E and F, it is clear that set E and F both are the closed interval. Our set is the closed interval -1 to 0, and the set F is also a closed interval from 0 to 1. There is a single number that is common in both sets, that is 0. This end at 0 and this starts from 0. So there is a single number that is common in both. Clearly, E intersection F, this is a singleton set 0. Next we have to find the its direct image under F. F of E intersection F is equal to, what is the intersection F? This is a singleton set 0. By definition of direct image, you can write it as, this is a set F at 0. Because you know, what is the definition of direct image? The direct image of a set E, suppose E is any non-empty set, then direct image of set E is given by the set f of E represent a set. This is not a numerical value, this is a set of values. This is the set of values of all output of f when we apply f at elements of E. So this can be written as f of 0. What is f of 0? Our function f is x square, so put x is equal to 0 in the set. This becomes 0 because our f of 0 is 0 square, which is equal to 0. Next we have to prove f of E is equal to f of F, and both are the closed intervals. Next we have to find f of e and f of f. That is the direct image of e and f under the mapping f. Let us first find f of e. Here in the closed interval e, our x lies between -1 less than x less than equal to 0. These are the values of x. To find f of e means f of the closed interval -1 to 0. I convert these values of x into the form of my function f of x. My function f of x is equal to x square. If x lies between -1 to 0, this shows the square of these values will lies between 0 to 1. This shows as x square is equal to our f of x, it means our f of x lies between 0 to 1. And because these x belong to e, this shows the direct image of e under f, that is f of e is equal to the closed interval 0 less than equal to y less than equal to 1. Because these are the output values, so that's why we will take here the variable y for the range. This is equal to 0 to 1, which is required. Similarly, when you apply mapping f on this set f, then again we will have the same result. You can check f of f is equal to 0 to 1 also. So this shows that the direct image of both sets E and F under the mapping F is same, that is the closed interval 0 to 1. Next we have to show that f of E intersection F is the proper subset of f of E intersection f of f. F of E intersection F. We have calculated f of E intersection F. E intersection F is just the singleton set 0. So this is this we have already find. This was 0, where f of E intersection f of f. F of E, these are both are same, and this is equal to closed interval 0 to 1. So the intersection of this set with itself is again a closed interval 0 to 1. This shows that clearly this set, singleton set, is a subset of this. This set is clearly a proper subset of 0 to 1, which is required to prove. Last one. What happens if 0 is deleted from the set E and F? If we delete 0 from E and F, if we delete 0 from this set E and F, then our set E becomes -1 to 0 open, and similarly our F becomes open 0 1 close. Now in this case, the intersection of E and F, this is empty, and the direct image of this set under the mapping F, that is this, because the direct image is always calculated for a non-empty set. It is obvious that when our set is empty, then its direct image under any mapping F is always empty set. So this is an empty set in this case. While the right hand side, f of E intersection f of f, what would be this? F of f. In this case, the direct image of this set -1 to 0. This is equal to, because now 0 is not a part of this set. So in this case, direct image is 0 less than y less than or equal to 1. Because when we apply f on these values, our f is x square. So all the negative values becomes positive, but 0 is not included. That's why we will now take here equal sign. So this is the now direct image of this. And similarly, when you find this is f of E. E is -1 to 0. Similarly, when we find f of f, 0 to 1, 0 to 1 close. This is again same, 0 less than y less than or equal to 1. So when we find the intersection of these two, this is again f of E intersection f of f. This is again semi-open, semi-closed interval, that is this. So if we delete 0, then again in this case, this set f of E intersection f, that is empty set, this is clearly a proper subset of this set. So if we delete this number 0 from this set E and f, this set is again a proper subset of this. Next, we move towards question number 13. Question number 13 is a very easy question. I hope you can do by yourself. Otherwise, at the end of the video, I will share the solution of the question. I am solving here question number 14. Okay, next we discuss question number 14. Question number 14 is a proof type question. In this question, we have to show that if F is a mapping from set A to B, and E and F both are the subsets of set A, then we have to show that the direct image of the union of E union F under F, this is equal to the union of their separate images. While in the case of intersection, this is a subset of intersection of separated images. I will prove the first part of the question, and I hope you can do the second part by yourself. So let us start from the method. When we have to prove a certain set A is a subset of certain set A is equal to set B, then the method that we use, we prove first A is a subset of B, and similarly we prove B is a subset of A. For this we choose any arbitrary element X from the set A, and later we show that X is also an element of B. This leads to A is a subset of B. Similarly, conversely, we suppose Y is an arbitrary element of B, then we show Y is an element of A. Then combining 1 and 2, we conclude that A is equal to B. So to prove first part, I will use the same technique, but I will use here the concept of direct images also. To prove one, we show that f of E union F. Firstly, this is a subset of f of E union f of f, and vice versa. Vice versa means then f of E union f of f. This is also subset of f of union f. So let us assume an arbitrary element y from this set. Let y is an arbitrary element of the set E union F. Again, remember that this notion represents a set. This is not a number. So that's why let y is an arbitrary element of F. Then by definition of direct image, then by definition of direct image, there exists an element x belong to the set E union F such that y is equal to f of x. This is the definition of direct image. If y is an arbitrary element from the set of direct images, then there exists a pre-image. There exists a pre-image x. There exists a so then by definition of x, there exists a pre-image x belong to this set such that y is equal to f of x. So now I use the definition of union. If x is an element of this union, this implies x belong to E, either x belong to E or x belong to F. Again, if x is a pre-image or x is an element of E, then f of x, this belong to f of E. Similarly, f of x belong to, if x belong to f, then or x belong to f of f. This again by using the definition of union, it means f of x belong to f of E union f of f, or I can write y belong to f of E union f of f, because y is equal to f of x. Next, we will write as y is an arbitrary element of the set this. Now y belong to this set. This implies this set f of E union f is a subset of f of E union f of f. Say this is 1. Next, conversely, we suppose that f now y belong to this right side. Conversely, suppose that let y belong to f of E union f of f. This implies by definition of union y is an element of either one of them, y belong to f of e or y belong to f of f. If y is an element of f of e, this implies there exists a pre-image x belong to set x, set e, or x belong to set f. This shows our x belong to the union E union F. If x is an element of E union F, then by definition of direct image there exists a y. This implies f of x belong to the set f of E union F. Or we can write y belong to f of union f of f, E union F. Again we will write as y was an arbitrary element of this set. Now y is an element of this. This shows that now this is a subset of this side. By combining 1 and 2, we will say both the sides are equal. So this is the concept behind the questions. I hope you have now clear understanding about these questions. Still, if you have any question, any query, you can ask me. Inshallah, I will reply you. In the next lecture, we will discuss next questions available in the exercise. Take care. Inshallah, I will see you in the next lecture. Take care. Allah Hafiz.